Okay, so far in this problem, we're doing the same problem. We've figured out, if you look back at your notes, okay, we figured out that the sides, opposite sides, were parallel. Okay, we have proven that to be true. Okay, second thing we have proven, we've proven that the diagonals bisect each other. We did that with the midpoints. Okay. Third thing we've proven is that the diagonals are perpendicular. Okay. So now we're going to continue on and we're going to look at the sides. What is the length of the sides? Okay, do I have 4 congruent sides? That's what we're going to determine now. So we need to do the length of sides. Okay, this is going to be our fourth thing that we're going to work on now. Okay, so we need to first find the length of side AD. Okay, now if you look back at your picture, point A was -4, 8, and point D was -9, 2. All right, we'll use distance formula on that. We don't need to get a decimal for it. We just need to know what this number is. Remember, to do distance formula, you take the second x, -9, subtract the first x, -4, square it, add to it the second y, 2, subtract the first y, 8, square it. Okay, look back at your notes on distance formula if you forgot the formula. It's just x2 minus x1 squared plus y2 minus y1 squared. Alright, so this minus minus here is going to turn into plus. So we're going to have that it's the square root of -9 plus 4 is -5. Square it, that's 25. 2 minus 8, that is -6. Square it, and that is 36. Okay, 25 plus 36 is going to be 61. So square root of 61 is the length of side AD. Now you have to do this for all 4 sides. So let's go to the next side, AB. Okay, AB, the 2 points for AB are -4, 8 and 2, 3. Again, just referring back to the picture. I know I don't have it up here on the screen. It doesn't fit at the same time. There's a lot of work to these problems. So this is what I have. So now the distance equals, okay, big square root of, let's see, we're going to do x2, 2, minus x1, -4, square it, add to it y2, which is 3, minus y1, which is 8, square it. Okay, so distance is going to equal the big square root, minus minus here turns to plus. So 2 plus 4 is 6, 6 squared is 36. 3 minus 8 is -5, square it, that's 25. 36 plus 25 is the square root of 61. Alright, let's keep going. Next side that we want to find is BC. So let's do it for BC. You have to do it for all 4 sides. Okay, if you're trying to prove that it's a square or a rhombus, you have to show that all 4 sides are congruent. So for BC now, we have 2, 3, and -3, -3. Alright, distance formula equals big square root. We're going to do x2, -3, minus x1, 2, square it. Add to it y2, -3, subtract y1, 3, square it. Okay, this is going to give us the square root of, this is going to be -5, -3 minus 2 is -5, square it, that's 25. -3 minus 3, that is -6, square it, that's 36. So 25 plus 36 again is the square root of 61. So at this point, I've really shown all the sides to be congruent, but let's do it for the 4th side also. Okay, because of it being a parallelogram, you already know that opposite sides will be congruent. We already proved it was a parallelogram with opposite sides being parallel and the diagonals bisecting. But let's continue. Let's do the last side here. The final side would be side DC, which side DC has the points -3, -3, and negative 9, comma 2. Okay. So now same thing, distance formula equals big square root. Okay, of x2, negative 9, subtract negative 3, square it. Add to it 2 minus negative 3, square it. So this negative 9 minus minus turns to plus, so distance is going to equal the square root of negative 9 plus 3 is negative 6, squared it's 36. Minus minus turns to plus here, 2 plus 3 is 5, square it, that's 25, and this is the square root of 61. So again, have you shown all four sides to be congruent now? Yes. So you have four congruent sides. That brings into play that it could be a rhombus or square, because rhombus or square have four congruent sides. All right. Now, how do you show that it's a square more strongly than it is a rhombus? The last thing that you could do here is you could find the length of the diagonals. If the diagonals are congruent, then it is definitely a square also, because a square has everything. It has four congruent sides, which we figured out. It has four right angles. We already talked about that the opposite sides were perpendicular, the consecutive sides, sorry, were perpendicular, so that made it a square. Let's check real quick with the diagonals, though. So let's do the distance of the diagonals. And this would be kind of your final thing that you could do on any of these questions. So the diagonals, AC, is going to be the point negative 4, comma 8, and negative 3, comma negative 3. So let's find the distance of that diagonal. So that's going to be the big square root of x2 minus x1 squared plus y2 minus y1 squared. We're trying to find the length of the diagonals. So this is going to be minus minus turning to plus. Negative 3 plus 4 is 1. 1 squared is 1. Negative 3 minus 8, that's negative 11. Square it, that is 121. 11 times 11. And so the diagonal length is the square root of 122 for AC. Now let's do the same for the other diagonal, DB. And so for DB, the 2 points are negative 9, comma 2. Just looking at my picture here. And then 2, comma 3. Alright, so let's find the distance there. Distance equals the big square root of x2 minus x1 squared plus y2 minus y1 squared. Distance equals, you've got 2 minus minus turns to plus, that's 11 squared, 121. 3 minus 2 is 1, 1 squared is 1. So 121 plus 1, again the distance is the square root of 122. So here's what we have at this point. Because the diagonals are congruent, it is a rectangle. But again, the strongest statement you can make is what you're looking for. We're going to say this shape was a square. And what would be your reasons for that? Okay, lots of things. Number one, opposite sides were parallel. Consecutive sides were perpendicular, which gave us 4 right angles. The diagonals were congruent and perpendicular. And all 4 sides were congruent. So again, if you know your properties of your shapes and you go through all the parts that I just showed you here today, you're going to feel like you can do this. All right? So again, what I want you to do today as what you're going to submit on Google Classroom is all the notes from these videos. You can go back and do it again if you didn't take notes, but that's what you're going to submit, is you're going to submit on Google Classroom all of the notes that you took in the 3 videos that have been given here today. All right? So if you didn't take the notes, you got to go back and rewatch it, redo them, and then submit on Google Classroom. On Thursday this week, we will have one more day of review on this, and next week, Tuesday, then, is the test. All right, go back and take those notes if you haven't, and submit them on Google Classroom by midnight tonight. All right, everybody have a great day. We'll talk to you again on Thursday.